So first you have shown that this sequence converges. How you have shown that this is monotonic increasing sequence and it is bounded above is not it bounded above and monotonically increasing, so it will converge. And also in previously you have seen in your 12th class taking logarithmic and L'Hopital's rule. So if you take this, suppose this is a limit a, suppose then if you take log a both side, then you can calculate using L'Hopital's rule and you will get log a equals to 1. So a will be e, is not it? So this is already you know. Is it clear? The limit, this is famous sequence. So you should know how to prove the limit is e and why the sequence converges. So y part is monotone increasing and bounded above. So it will converge and it will converge to you. You can calculate explicitly. So it is clear because it is famous sequence. You will need it again and again to prove convergence of other sequence. Okay. Then also in series also it will be needed sometimes. So what will be the limit of 1 plus 2 to the power 1 by 2 n by n. So what will be the limit of this sequence? Can anyone tell me? You have studied subsequence also.
e की पावर 1 by 2
प्रोटीन के उदाहरण है सब्जियां, मटर, दालें, खनियां।
E की power
1 by 2।
how you got?
सर इसका तो मतलब स्टैंडर्ड मेथड होता है, मतलब 1 माइनस e की पावर।
Okay, so but suppose you have to give some
लॉग लेके
logic,
भी कर
right?
सकते हैं, लॉग लेके भी कर सकते हैं।
लॉग लेके कर सकते हो। सपोज लॉग लेके नहीं करना है, सपोज इसको यूज करके करना है, जो तुम्हारा सीक्वेंस 1/1 प्लस n टू द n है, ये कन्वर्जेंस अगर ये है तो ये किस में कन्वर्ज होगा? अगर इसको यूज करके करना है तब क्या करोगे? You understood my question?
No, some
Suppose we know that 1 plus 1 by n to the power n converges to e. Using this, I will show that where this sequence will converge 1 plus 1 by 2n to the power n. The answer is okay, e to the power half, but how will show it? You have to use only this one. So you have studied subsequence, right? What is the property of subsequence? You should not forget all these properties.
सीक्वेंस में मतलब कोई भी नंबर अगर छोटे से नंबर सीक्वेंस में लेंगे तो वो सब सीक्वेंस हो जाएगा उसका।
और प्रॉपर्टी क्या है कन्वर्जेंस का? कि if a sequence converges to some limit, suppose L, then what will happen? If a sequence converges to L, then what will happen for the subsequence limit? Since you have not studied, huh?
But it will also converge.
See, I have written here. If a sequence in lecture 6, it seems you have not studied. If a sequence n converges to L, then every subsequence of n also converges to L, is not it? See,
Yes, sir.
that means you have not studied properly. So, tell me one subsequence of this sequence. Tell me one subsequence of this sequence. This is your main sequence. Now tell me one subsequence. At least you should tell this at least, right?
फिर n+1
Huh? So you can take the event term, right? Is not it? You can take the event term. Then what will be the sequence if you take the event term only? Tell me 1 plus 1 by 1 by
2
2 2n to the power
जब तो हम
to the power to the power what?
2n.
2n. Is it clear? Suppose un is 1 plus 1 by n to the power n. So what will be 2n? 2n will be, this is one subsequence. 1 plus 1 by 2n to the power 2n. So since this sequence converges to E, so this subsequence will also converges to
E.
E. Now you have to show the limit of this sequence. That you can see, right? So it's nothing but square root of this sequence, right? It's not it. This one, right? So it will converges to e to the power half square root of e. Is it clear? Is it clear?
Sir.
So please complete the proof that this UN sequence monotonic increasing already you have seen, but this part I kept some part remaining, right? In lecture 6, I told you to complete it. Please complete it. Lecture 6, right? Let me see. Lecture 6 or what? Maybe lecture 5, right? Yes. So I told you, see, already you have started here and you have just one line. What is that? In just one line.
Binomial expansion. Binomial
Yeah,
expansion.
so you have to use factorial
Binomial
n.
expansion.
Factorial n greater than 2 to the power n minus
Or n
1.
minus 1.
For all n greater than 2. That you have to use only. Then you can prove lesser equals to, you can keep it. This is all less than 1. So last part is 1 upon 2 to the power n. Factorial n. So 2 to the power n minus 1 will be there. So ultimately, this term will be bounded by, so n will be ultimately bounded by what? n will be ultimately bounded by, so here un will be ultimately bounded by what? If you use factorial n greater than 2 to the n minus 1, so ultimately un is bounded by 1 plus 1 plus half factorial up to 1 plus n factorial, right? So that will be 1 plus 1 plus half plus half square up to 2 to the power n minus 1. And this summation should be, so you can, that at least you can do, right? That at least you can do, is not it? So 1 plus this series finite, so that you know, right? What will be that? 1 plus 2. Is not it? 1 plus, is it clear? Is it clear or not? And this is less than 3. So un is less than 3. So now you know that this sequence 1 plus 1 by n to the power n, it will converge because it is not bounded, and already you have shown that it is, it is monotonically increasing. So already you have shown that it is monotonically increasing. So this will converge. So also you have seen that this also you have seen, right? The definition of E. Have you seen this definition? This is already you have seen, right? So for this series, what will be the sequence of partial sum? For this series, what will be the sequence of partial sum? Okay. So from here, so do you know what is rational or irrational?
Irrational.
Irrational. So how you have shown it? How you have shown it? Yeah, please. Someone is talking. Please mute yourself. So how you have shown that this is irrational, or you have just know as a statement? What is that? You just know as a statement or what? Hmm? You just know this as a statement, or you know the proof also? Is irrational. Suppose you want to show. I'll show this. Can anyone guess? So we'll show this in 2 steps. Suppose by a method of contradiction, suppose E is rational, right? Suppose her method of contradiction is rational. So E is suppose of the form P by Q. Suppose E is rational. Okay. So what is P and Q? P and Q are positive integers. Okay. So what will be this value? E minus Sn. What will be this value? E minus Sn. So it will start from 1 plus n 1 by n plus 1 factorial, right? Then 1 plus n plus 2 factorial. Is this clear? Now if you take 1 by n plus 1 factorial common, what will get? What will get? If you take 1 by 1 plus n plus 1 factorial common, what will get? Can anyone
1
calculate?
plus
Hmm.
1
1
plus
plus 1 upon n plus
upon
2.
n plus 2 plus
1
1
upon n
upon n
plus
plus
2.
3.
N plus so that can be less or equal less than. So that can be less than. Is this correct? Is this correct or not? Is this correct or not?
Yes, sir.
Is it correct, everyone? So you have what you have used here. So this is your like that, right? Then what you have used? Then what you have used? This n plus 2 is greater than 1 by n plus 1, right? N plus 3 is greater than n plus 1. So ultimately you will get this one. Is it clear? So what will be the sum? So E minus Sn will be, and this is already positive. So ultimately what this will be less than what? This value will be 1 by n plus 1 factorial into what value? This geometric series. What will get? This geometric series, what will get? Hmm? 1 upon 1 by. Is this clear? Just A by 1 minus R, right? A is 1 and R is 1 by n plus 1. Is it clear? So ultimately you are getting factorial n into n. Is it okay? Is it okay or not?
Yes, sir.
So, and you have assumed that suppose E is rational, so E is P by Q. Okay. So that means what we'll get? That means what we'll get? So if you use this property, you will get 0 E minus SQ less than del Q. If you use this property, you will get this. Is it clear till now?
Yes, sir.
So now you have to show some contradiction, right? And what will be that contradiction? What will be that contradiction? You have to show some contradiction. What will be the contradiction? Can you guess from here? Can you guess from here? Can you guess from here? Oh, this is a 1 by n also, right? You have not calculated, it seems. You are just sitting. So this is what? I think you have not calculated. 1 by n plus 1 factorial, n plus 1 by n, right? So 1 by n factorial. So that means this will be your answer, and you are sitting like a. Is not it?
Yes, sir.
So
Yes.
so now you have to show that this is an integer. So that will be your contradiction. Now since you have seen that E equals to P by Q, so this factor will be an integer, you have to show this factor is also, this term will also an integer. So this will be integer, but this and this is some number, right? 1 by Q. So in between 0 and 1 by Q, there will be no integer, right? Is it clear? Because Q is already greater equals to 1. Is it clear or not?
Yes, sir.
Okay. So how will show this? How will show this? How will show this? How you show? So E is your P by Q, right? That you have already assumed. That means P equals to E Q. So this is an integer. Now, what about this one? factorial q into e. Is this an integer or not? What is q factorial e?
Yes, sir. It is also integer.
Why?
Sir,
Why?
because E,
Hmm.
sir, if P equals to E and Q, then sir, E is an integer. Sir, you said that E is an integer.
No, I have not said e is an integer. E is rational. We have considered e is rational. E is rational, then we have to find a contradiction.
Sir, we have considered E as P by Q. Then if we multiply it by Q factorial, then we'll get Q minus 1 factorial times P, which will be an integer.
Yeah, so this factorial integer that we have to show
sir.
first. So this is
Yes, sir.
nothing but your
Q minus 1 factorial into P, which is an integer.
So this is your like p into q minus 1 factorial, right?
Yes, sir. And here
Yes,
E is
sir.
equal to P by Q.
Already have put it equals to p by q, right? So p is already an integer, is not it? P and q are integers.
Yes. Yes, sir.
So ultimately you are getting this one, right? Since q is an integer, so this is an integer. Now how will show that factorial q sq? Similarly, you can calculate, right? Factorial q sq. What will be the value? What will be factorial q sq? Factorial q. What is sq? 1 plus 1 plus 1 by 2 factorial plus 1 plus 1 by q factorial, right? Is this integer or not? Is it integer or not?
No, sir.
Huh? This is not an integer. This will also be an integer, right? Why it is not an integer? What will get? Factorial q plus
factorial q plus
Yes, sir. Yes, sir. Yes, sir. Yes,
so
sir.
last term you can see that 1 will be there, right?
yes, sir.
Is not it? So second last will be what? Second last will be
factorial.
huh?
2 factorial.
No, second, so here will be 1 by q minus 1 factorial, right? So if you multiply by q, so this will be your q, right?
Q. Yes,
Not
sir.
it. So ultimately, and this one here, q into q minus 1 up to 3,
Up to 3.
then 1. Is not it?
Yes, sir.
So this is an integer. Is also an integer. And q is your not g. So q is like greater or equals to 1. So what will happen?
Difference of two integers can't be a fraction.
Yeah, so this is, so no integer can lie, right? This is an integer, this is an integer. So no integer can lie between 0 and 1. Is it clear?
Yes, sir.
So a contradiction. No integer can lie between 0 and 1.
सर
So,
हमने e को समेशन 1 by n फैक्टोरियल कैसे लिखा सर? वो समझ में नहीं आया शुरू में बिल्कुल जो आपने
वो
बताया.
तो डेफिनेशन लिखा ये है ना.
यस सर.
हाँ. But if we know this, okay, that this converges to E,
Yes,
you
sir.
can show that this series will also converges to E by monotonicity and all this property, okay? This is your exercise. If you cannot do, let me know in tomorrow's tutorial class. Okay, this is definition. So somewhere you have to see that this is definition. Once you start from somewhere, you can prove. Suppose you know the limit. Okay, you know already this limit, right? Now you can show that this sequence, this series will also converges to E. Okay, so that means sequence of partial sum, if you consider, it will converges to E. So if a series will converges to E, that means its corresponding sequence of partial sum, that sequence should converges to E. Is not it? So please try on your own. If you have any difficulty, you can ask tomorrow. So that means you have to do something. So you have to use it to prove the convergence of this series. Okay. So please try. Any other difficulty? Any other difficulty?
No, sir.
So,
Sir, please scroll up the page.
huh?
Sir, please scroll down the page.
Okay.
Yes, sir. No, here.
This one?
No, sir. Up. Up.
Answer.
Yes, sir. Here.
Okay. So yesterday you have seen some test, right? For series convergent. Is not
Sir, how
it?
have you?
Huh?
Sir, this one.
Which
Sir,
one?
how have you? Sir, this E minus SN.
Which one? Which
Please
line?
explain this.
Uh,
Sir, this.
this one.
Yes, sir. How have you written this, sir?
So I have proved it, right? Is this clear? E minus Sn will be this.
Yes, sir. From here, please tell.
Then E minus Sn this, that means this is equals to this line. Is it clear? 1 by n factorial n plus 2 into n plus 1 factorial n plus 3. Then I have used this inequality. N plus 2 is greater than n plus 1, n plus 3 is greater than. That means 1 by n plus 2 is less than 1 by n plus 1. 1 by n plus 3 is also less. So every term will be less than n plus 1. 1 by n plus some p will be less than. Is it clear?
Yes, sir.
So once you use this, you will get this line. 1 by, is it clear? Is this line? Is this clear or not? So this term
Yes.
is less than this term is less than 1 by 1 plus n plus 1 into n plus 1 factorial. This term will be less than 1 by n plus 1 square, because both term is less than 1 by n plus 1. So n plus 1 square into n plus 1 factorial. So you have taken n plus 1 factorial common, so you will get 1 plus n plus 1 and like this. So this is a geometric series, right? So its summation will be a by, so a plus a square, is not it? 1 plus a square. This already you have seen in the yesterday's class or what? Or before that? Already many classes. This you have seen, right? This you have seen or not? 1 by 1 plus a, 1 minus a. So 1 by 1 minus 1 is n plus 1. And outside 1 by n plus 1 factorial is their multiplication. So this will be 1 by factorial n into n. Is this clear? So if 0 less than e minus Sn less than 1 by factorial n n for n, so it will be for any n, it will be true, right? So we have put instead of n q, so we will get this inequality. Is it clear? Then you have multiply both side by q factorial, so you will get this one. Now from here we have to show one contradiction. So how you show that contradiction? Suppose we have shown that this is an integer. So any integer, so no integer cannot lie. No integer can lie in 0 and 1. Is it clear or not?
Yes, sir.
There is no integer between 0 and 1. Is it clear? that we have
Yes, sir.
shown by a contradiction. So our assumption is wrong. That means E is irrational. Is it clear?
Yes, sir.
So this is important property. Okay, please go through once more that how you have shown E is irrational. Okay. Is this clear? So please also try this one. I will show this. Once you suppose you know that this sequence converges to E, using that, whether you can show this sequence of partial sum for Sn of this series will also converges to E. That means you have to show that this sequence Sn, where Sn is 1 plus 1 by factorial 2, 1 plus up to 1 by factorial n, that is converges to E. Okay. So using 1 by 1 plus n to the power n converges to E, you have to show this sequence Sn converges to E. Once you have shown that this sequence Sn converges to E, and this Sn is nothing but sequence of partial sum for this series. So this series will also converges to E. Is it clear? So first you already know this. Using this, you have to show this, that for this sequence, the limit is E. Once this sequence converges to E, and this sequence is nothing but sequence of partial sum for this series. So this series will also converges to E. Because already you know, right? Whether a series will convergent or divergent, you can check according to the sequence for partial sum. Is not it? So yesterday you have seen also various tests, right? So suppose we have to check the convergence of this series. Okay. Examine convergence. X plus x square by 2 plus x cube by 3 x positive. So how will show? How will show? How will check the convergence of this series? So for which x it will converge, or for which x it will diverge? When x equals to 1, what will happen? When x equals to 1, what will happen?
We'll get 1 plus half plus 1 by 3 plus 1 by 4.
So this series will converge or diverge? This series will converge or diverge? Don't confuse, between the series and this sequence.
Converge.
Again, some people are saying it will converge. Huh? This is always diverge that you have
Diverge, yes, sir.
shown. So there is one necessary condition, right, for the series to be convergent. What is that?
X
What
not
is
equal
that?
to 1. X not
Huh?
equal to 1.
X not equals to 1. No,
Mod x will be
Limit
less
of the
than 1.
series is equal to 0.
not limit of the series. What is that? Limit of the
Series equal to 0.
limit of the
Then when-
nth term of the series.
Yes, sir.
Yes.
So that is a necessary condition. That does not mean that if nth term of the series goes to 0, that series will converge, right? And the example is this one. That nth term of the series goes to 0, that does not imply the series will converge, is not it? Because it is a necessary condition. If the series converges, then we will say if the series converges, then we will say if the series converges, then we will say the limit. So don't forget, if this series converges, then limit n 20 even equals to 0. But if the limit extends to UN 0, we don't know. We have to check. No conclusion, right? So that means it's a necessary condition. It's not sufficient. Is it clear? So this series is always divergent. Already you have shown it, right? So how will check the convergence? Suppose you have to apply D-Alembert. Using D-Alembert, can you tell me? Using D-Alembert, how will show? Using D-Alembert, how will show? What is UN plus 1 by UN? What is that? UN plus 1 by UN. What is that? UN plus 1 by UN. What do you mean by D-Alembert's ratio test? What do you mean by D-Alembert's ratio test? At least someone, what do you mean by D-Alembert's ratio test? That if a
Don't.
series, बताओ.
No, sir. Don't know, sir.
You don't know. In the last class, you have already seen if given a series of positive real numbers, given a series of positive real numbers, given a series of positive real numbers, if limit tends to UN plus 1 by UN equals to L, then if L less than 1, then UN is convergent. If L greater than 1, UN is divergent. If L equals to 1, no conclusion. Right? So you have to calculate what is L. And what will be L here? So you have to calculate what is L here. So when L less than 1, it will be, UN will be convergent. Is not it? So what is L here? What is L here? What is L here? What is L here? What is UN? First, tell me what is UN for this series.
X
What
की
is
power
UN?
n, x की power n divided by n.
X to the power n divided by n. So what will be your UN plus 1 by UN?
तो वो हो जाएगा x 1 by x into n plus 1 by n.
So ultimately, what will be there?
Sir, x into 1 plus 1 by n.
X into
1, sir.
So what will be there? X into
1 plus 1 by n.
1 plus 1 by n. Numerator or what?
सर ब्रैकेट में होगा सर, ब्रैकेट में 1 plus 1 by n.
This you are saying?
Yes sir.
This you are saying or not?
Yes sir.
Or
Yes.
huh?
Yes sir.
Is not it? Into so you will get this one, right? So what will be the limit n tends to infinity? UN plus 1 by UN. What will be the limit? What will be the limit? At least you should tell what is the limit of this un plus 1 by un. Huh?
Sir, x.
X, right? Because this value will goes to 1, and you know that if I think I don't know if this goes to 1, then scalar multiplication of this series will goes to this sequence will goes to C. So already you have seen how will show that this sequence converges to 1. Huh? You can show by various ways, right? Using epsilon in definition, you can show it in various ways. Okay, and you can also see that in what will be the limit. You can check. So if x is less than 1, what will happen? So if x is less than 1, what will happen?
Convergent.
Then the series even is convergent. If x is greater than 1, then even is divergent. What about x equals to 1?
No confusion.
No, here you can conclude for particular series. Here you will get one series, right? No conclusion, that is for theory, because that is for arbitrary series of positive real numbers. But here the series is given, right? So no conclusion, that is for test. So for individual series, you have to check.
Divergent.
So for x equals to 1, you will get the series 1 by n, and which is divergent, that we have already shown. Okay, so you have any doubt? You have any doubt? You have any doubt, or you can prove it now? Suppose this one 1 plus 1 by factorial 1. I will show whether this series will converge or not. At least you should tell me this one. This already you have shown it. I will show this series will converge or diverge.
Sir, first we'll check for n raised to power n divided by n factorial when n tends to infinity.
So what is un here?
N raised to the power n when divided by n factorial.
What is un here?
N raised to the power n divided by n factorial.
So what will be the un plus 1 by un? So what will be your un plus 1 by un here? Calculate and tell me. Because this you know and you should give the answer. So this is your series un. What will be the un plus 1 by un?
Calculating.
Okay.
Sir, it will be n plus 1 divided by n whole raised to the power n.
Right. So what will be the value? Limit n tends to infinity. What will be the value?
Sir, E, sir.
Yes. So what is the conclusion?
So that it converges to E.
Huh?
Series converges to E.
You already close to, but up to this is correct. Then what is the conclusion? Up to this is correct. Then what is the conclusion about the series UN?
Sir, divergent.
Why?
Divergent.
Why?
E is greater
E
than
is
1.
positive.
Yes, because E is greater than 1, right?
Yes, sir.
Is it correct? Who is that? Who has calculated this limit? So up to this E is correct, right? Now since E greater than 1, so what will happen? By D'Alembert test?
Divergent.
So don't think that if E had come, it is E, so it will come. No, right? So already you know that this E is greater than 1. So you know already value of E, right? 2.73 something, right? Is not it? So any difficulty till now? So please complete this one. Okay, this is your exercise using this one, whether this sequence Sn will converges to E or not. Okay, once you know that this sequence of partial sum Sn converges to E, so the series 1 by n factorial summation n equals to 0 to infinity, that will also converges to E. Is it okay? So you have any class now?
Yes, sir.
Okay.
Yes, sir.
Okay, see you tomorrow.
Recording stopped.